Hello and welcome to C programming video. My name is David Thorne, and in this video I'm going to show you how to dynamically allocate memory when dealing with files and reading data from files. And with that said, you can see here we've got this simple text file with some text here. This is on line 1, on the other line with a different length, and then some text that's more than 255 bytes in length. That will become apparent shortly. An empty line, another line, an empty line, then the final character here. So this is the file that we want to read and hopefully then output it to the console. So with that said, we've got our C file. The first thing that we want to do is create a file descriptor, and we use then the file here, and we're going to say fd as the variable name as a file descriptor. Next we are going to say fopen, and here we're going to need to give the path to the file. And at the moment I've got the file on my desktop, and it is called myfile.txt. And we need to say what mode we're going to use, and we're just going to use the read mode. And it could be then the write mode, or it could be the append mode. But in this example, we're just doing reading here. So just to be nice and safe, we just need to check if then the file descriptor is equal to null. And if it is, we'll just return, I don't know, 1, and just say printf could not open file for reading. And we can just print down here opened file for reading, and obviously I'm going to fix the typos and also this. We want printf, not that whatever I wrote there. And let's put this at the end like this, and a semicolon as well. So, and don't forget, once we've finished with the file descriptor, we want to close it as well by calling fclose at the bottom. So we can run this just to check to see whether we found the file, and we didn't. Oh, and it's David Thorne. There we go. And now it accessed the file. So now we have a file descriptor for that one file, and obviously we've then closed it here, which is perfectly fine. So the thing that we want to do with dynamically allocating memory is that we want to basically create a buffer, and this buffer is going to be, this is going to be a char string, right? Because we want to take the whole contents of it and place it into a buffer, right? Now we don't know the size of this one buffer. We don't know the size of the file, and we won't know it until we've actually completely finished looking at the contents of the file, all right? So we need to allocate some memory here based upon, first of all, the size of a char, and we're going to have chunks of data being read, and we're going to increment this buffer as per the buffer size. And as we go through and we reach that buffer size, we're then going to double that buffer size all the time. Remember, binary loves the powers of 2, so when we start with one set of size of the buffer, we're going to double it again, or keeping that that idea. So we're just going to use a size t here, and I'm going to say buffer size is equal to 256 in the beginning. And like I said, every single time we reach this size of the buffer, we will reallocate more memory, doubling this every single time. Now we want to basically read from this file character by character, and every single time we get a character, we're going to add it to this buffer. But we need to check basically if the count of the number of bytes that we've loaded already, right, is if it's less than the buffer size that we've got, because this is going to keep the size of the buffer in total. So we're always going to modify this based upon how big our buffer currently is. And every single time we get a character from it, we're going to increment the count. That's going to be the index of our first char. So we're just going to say size t is equal to counts, and this is going to be the current chart that we're going to be on first of all. All right, so we need to first of all read from this one buffer as we go through, and we want to check to make sure that it's not equal to the end of file, all right? But we need a char that the C is going to be a char that we're going to read from, and we're just going to say fget C, so we're going to read a char every single time from this file descriptor, and so we can just say fd here. So now we need this char that we're going to read from, okay? And like I said, inside of our while loop, we're going to update the count every single time we get a new char. It's really important that we don't forget to do this, all right? And at the end of it, we need to free the buffer as well, okay? So we're just making sure we handle all of the important things because we are managing memory here, and we've got a while loop that we need to make sure we exit out of. So when we get the first character, if that's not equal to the end of file, then obviously we're going to come into this code. So let's just get the important thing done first and say count. So the index of count, we're going to set that to, so the within inside of the buffer's index of 0, which is going to be in the beginning, we're going to set it to this one character, okay? Now, when it gets to the end, we might have, let's say, 500 bytes within inside of this buffer, right? If it's been increased, that have chars, and that is the end of the file, right? So when we come to the end of it, we want to say, first of all, if count is more than 0, right, then we know we've got at least one character inside of that one buffer. We've got to set the null terminator as well. So we're just going to say buffer counts, and we're going to say equal to then the \0, all right? Remember, when we've set this, we've done count plus plus to be the next position always. So we know we're safe to set this as \0, which this will tell any print f that we're going to do, where we say then we'll just print out the buffer. So at the end, once we have this one buffer, we're going to print it out. So now the only logic that we've got left is we need to check, first of all, do we have enough memory in here? Okay, so we're going to do it like count plus 1 first of all, right? We're going to check to see whether this, right, is less than our buffer size, right? And if count plus 1 is less than buffer size, then we know we can update that one buffer, no problem, right? Otherwise, we know that by increment this count by 1, we're going to be equal to this buffer size. So we've got to reallocate this one buffer, and we're going to do that by then say reallocate buffer, and here we then need buffer size as well. But before we do that, we need to update this buffer size to be twice the size, and we can do that by saying buffer size times by 2. So we're just doubling it inside. And now we need to check to see whether we got an actual buffer or whether we got null. And if we got the buffer is now null, we had a memory problem or something like that, we're just going to return 2, and we're just going to say print f, then there was a problem allocating memory. And here, obviously, we need to say fclose the file descriptor, because obviously here we're going to exit out, we're never going to come down here. This memory has already been corrupted, so we don't really have to free it. So this now, let's just have a go over this. We check to see whether we have a file descriptor. If we're equal to null, we could not open the file. We've tried that already. We then create our buffer size in the beginning, and we allocate a buffer based upon the size of chars times by the buffer. So we now have our buffer. We set the count to 0 to say this is the first index of the first char. We create our char that's going to be updated all the time. And now we say read the first char from the file descriptor, which sets this to have a value. It then checks to see if it's not equal to the end of file, then we go into the loop, all right? If it is equal to the end of the file, we then come out here and we say if the count has been incremented by at least 1, we're going to make the count put the current index equal to the null terminator, so we can then print it out, and then we can get rid of this. We're coming down here, we're freeing the buffer, and we're closing the file descriptor, and we're returning 0, right? If it's not equal to the end of file, we know that we've got a buffer of 256. So if the count is currently on, say, 255, right, and we plus 1, we then know we're on 256, which means that the index of 255 is already going to be full in the buffer. So we need to double it already, okay? So that's why if it's on 255, we've already set 255 in here already. So by plussing it by 1 means we're out of bounds of memory where we need to increase the size. If we're less than 255, or less than equal to, sorry, if we're less than 255, we can still increment by 1, place it here. Otherwise, we double the size of the buffer, first of all, the number, and then we reallocate the buffer to be double the amount of size. Remember, this is efficiency for the memory because it loves doubling the size already. So we're keeping that one pattern. And we check to see if the buffer is null. If it is, we print out there was a problem, we close the descriptor, and we return 2. If this was all successful, we now increment count by 1, and we come back into the loop, we read the next character, and we check whether it's the end of file, and so on. And we've already talked about the other things. So we should be able to run this right now, and it should work first time. We need to request access. And we can see here that it didn't go through to here. So let's just check this. My mistake. We didn't update the buffer here either, right? So we have a new buffer, and now we have to add the data to the buffer when it came through. All right, so let's just go again, and this time we do get it. So that was the only mistake, but because we didn't update that one index here, we created the new buffer, and we should have done that once again. So now you can see this is on one line, and then we have the long text here. We have the new line, and then this is the last line, and this is the last character here, exactly how it was with inside of our file just here. So this shows you that this just shows you how you can create a piece of memory, right? And by setting the /0, the null terminator at the end of it, we can use that one buffer elsewhere. Now, obviously, we could just make this even better, right? And say reallocate here the buffer here to buffer size. So it's actually going to reallocate it to the correct size of memory instead. And now we output it, and you can see here we've now got the same thing. So we are kind of saying to the memory in the background, hey, we only need this amount of memory, this buffer size. We don't need the rest. So whatever we allocated when we were doubling it, it could have just been two bytes on top of that, and we then used too much memory. So now we're saying, hey, just reallocate it. We only need this much memory instead, and just dump the rest of it after that. All right. So with that said, I hope this video has been informative to you. I hope you've learned something from it. Now, don't get me wrong, I'm no expert with the C programming language, but I'm moving closer and closer to working with IoT devices and working with embedded systems together with Swift programming language. So it's really important to me that I have this fluent knowledge in how to write especially to file descriptors, to streams, and read the bits out, because we're more interested in reading the small pieces of information through the transmitted from other microcontrollers of embedded systems on a bit by bit or a byte by byte basis to make sure that they're stored correctly in the memory. With that said, I hope you've got something out of this one video. If you did, don't forget to like, subscribe, share, and do all of the other social media things that you can do out there. Other than that, if you've got any questions, feedback, or concerns, as always, let's start a conversation in the comment section down below. Other than that, thanks very much for watching. My name's David Thorne. See you in the next video. Ciao, ciao, and goodbye.